Hello students, welcome to the lecture on Java Language Basics. And after the lecture we will be able to learn the following objectives. Explain the history of Java. Define the basic syntax of Java. Define the loop control. Explain about objects and classes. Let's start with a brief introduction to Java Language Basics. Java is a programming language created by James Gosling from Sun Microsystems, Sun, in 1991. The first publicly available version of Java, that is Java 1.0, was released in 1995. Sun Microsystems was acquired by the Oracle Corporation in 2010. Oracle has now the steermanship for Java. Over time, new enhanced versions of Java have been released. The current version of Java is Java 1.7, which is also known as Java 7. Java is an object-oriented programming language with a built-in application programming interface, API, that can handle graphics and user interfaces and that can be used to create applications or applets. Because of its rich set of APIs, similar to Macintosh and Windows, and its platform independence, Java can also be thought of as a platform in itself. Java also has standard libraries for doing mathematics. Now we will talk about the history of Java. Java was originally designed for interactive television, but it was too advanced for the digital cable television industry at the time. The language was initially called Oak, after an oak tree that stood outside Gosling's office. It went by the name Green later, and was later renamed Java, from Java coffee. Said to be consumed in large quantities by the language's creators, Gosling aimed to implement a virtual machine and a language that had a familiar C/C++ style of notation. Sun Microsystems released the first public implementation as Java 1.0 in 1995. It promised write once, run anywhere, providing no-cost runtimes on popular platforms. Fairly secure and featuring configurable security, it allowed network and file access restrictions. Major web browsers soon incorporated the ability to run Java applets within web pages, and Java quickly became popular. Here we will talk about the basic features of Java. Java has many features which are: Java is simple. There are various features that makes Java a simple language. Java is easy to learn and developed by taking the best features from other languages, mainly like C and C++. It is very easy to learn Java who has knowledge of object-oriented programming concepts. Java is platform independent. Java provides the facility to write once, run anywhere. Not even a single language is idle to this feature, but Java is closer to this feature. Java provides the facility of cross-platform programs by compiling an intermediate code known as bytecode. This bytecode can be interpreted on any systems which have Java Virtual Machine, JVM. Java is object-oriented. The object-oriented language must support the characteristics of OOPs. And Java is a fully object-oriented language. It supports all the characteristics needed to be object-oriented. In Java, everything is treated as objects, to which methods are applied. Java is distributed. The widely used protocols like HTTP and FTP are developed in Java. Internet programmers can call functions on these protocols and get access to files from any remote machine on the internet rather than writing codes on their local system. Java is secure. Java does not use memory pointers explicitly. All the programs in Java are run under an area known as the sandbox. Security Manager determines the accessibility options of a class like reading and writing a file to the local disk. Java is compiled and interpreted. We all know that in Java, code is compiled into bytecodes that are interpreted by Java Virtual Machines, JVM. This provides portability to any machine for which a virtual machine has been written. The interpreter program reads the source code and translates it on the fly into computations. Java is robust. Java has strong memory allocation and automatic garbage collection mechanism. It carries out type checking at both compile and runtime, making sure that every data structure has been clearly defined and typed. Java is portable. The feature of Java, write once, run anywhere, makes Java portable. Many types of computers and operating systems are used for programs by porting an interpreter for the Java virtual machine to any computer hardware operating system. One is assured that all code compiled for it will run on that system. This forms the basis for Java's portability. Now we will know about the Java virtual machine concepts. A Java virtual machine, JVM, enables a set of computer software programs and data structures to use a virtual machine model for the execution of other computer programs and scripts. The model used by a JVM accepts a form of computer intermediate language commonly referred to as Java bytecode. This language conceptually represents the instruction set of a stack-oriented capability architecture. Sun Microsystems claims there are over 4.5 billion JVM-enabled devices. The Java Virtual Machine, or JVM, is an abstract computer that runs compiled Java programs. The JVM is virtual because it is generally implemented in software on top of a real hardware platform and operating system. All Java programs are compiled for the JVM. Therefore, the JVM must be implemented on a particular platform before compiled Java programs will run on that platform. Java bytecodes. Java programs are compiled into a form called Java bytecode. The JVM executes Java bytecodes, so Java bytecodes can be thought of as the machine language of the JVM. The Java compiler reads Java language source files, translates the source into Java bytecodes, and places the bytecodes into class files. Virtual parts. The virtual hardware of the Java virtual machine can be divided into 4 basic parts: the registers, the stack, the garbage collected heap, and the method area. These parts are abstract just like the machine they compose, but they must exist in some form in every JVM implementation. Featured resource. The size of an address in the JVM is 32 bits. The JVM can therefore address up to 4 gigabytes of memory, with each memory location containing 1 byte. Each register in the JVM stores one 32-bit address. The stack, the garbage collected heap, and the method area reside somewhere within the 4 gigabytes of addressable memory. The exact location of these memory areas is a decision of the implementer of each particular JVM. Let's talk about basic syntax. When we consider a Java program, it can be defined as a collection of objects that communicate via invoking each other's methods. Let us now briefly look into what class, object, methods, and instance variables mean. Object. Objects have states and behaviors. Example: a dog has states color, name, breed, as well as behaviors: wagging, barking, and eating. An object is an instance of a class. Class. A class can be defined as a template, blueprint that describes the behaviors, states that object of its type support. Methods. A method is basically a behavior. A class can contain many methods. It is in the methods where the logics are written, data is manipulated, and all the actions are executed. Instance variables. Each object has its unique set of instance variables. An object state is created by the values assigned to these instance variables. Class names. For all class names, the first letter should be in uppercase. If several words are used to form a name of the class, each inner word's first letter should be in uppercase. Method names. All method names should start with a lowercase letter. If several words are used to form the name of the method, then each inner word's first letter should be in uppercase. Program file name. Name of the program file should exactly match the class name. When saving the file, one should save it using the class name and append .java to the end of the name. Java identifiers. All Java components require names. Names used for classes, variables, and methods are called identifiers. In Java, there are several points to remember about identifiers. They are: all identifiers should begin with a letter, currency character, or an underscore. After the first character, identifiers can have any combination of characters. A keyword cannot be used as an identifier. Most importantly, identifiers are case sensitive. Examples of legal identifiers: age, salary, value. Java modifiers. A modifier is a keyword placed in a class, method, or variable declaration that changes how it operates. In the Java programming language, the following keywords are modifiers: abstract, final, native, private, protected, public, static, strict FP, synchronized, transient, and volatile. Usage of these access modifiers is restricted to two levels. The two levels are class-level access modifiers and member-level access modifiers. 1. Class-level access modifiers. Only two access modifiers are allowed: public and no modifier. If a class is public, then it can be accessed from anywhere. If a class has no modifier, then it can only be accessed from same package. 2. Member-level access modifiers. Public and no modifier the same way as used in class level. Private, members can only access. Protected, can be accessed from same package and a subclass existing in any package can access. Java variables. Variables are used in a Java program to contain data that changes during the execution of the program. A variable is a container that stores a meaningful value that can be used throughout a program. Java variables can be categorized into 7 types. Class variable. A Java class variable is a field declared using the keyword static within a Java class, or with or without the keyword static within a Java interface declaration. Instance variable. Java variables that are declared without static keyword are instance variables. Array component. Array components are unnamed Java variables that are created and initialized to default values whenever a new Java array object is created. Method parameter. Java variables declared in the method declaration signature are method parameter variables. Whenever a Java method is invoked, a variable is created in the same name as it is declared. Constructor parameter. This is similar to the Java method parameter variable. The same way, for all the Java variables declared in the constructor, a variable is created whenever it is invoked. Exception handler parameter. Java variables that are declared in the catch clause of a Java exception handling mechanism. Whenever a Java exception is caught, exception handler parameter variable is created. Local variable. Java variables that are declared in a block inside a Java method or for loop is called a Java local variable. Now we will know about Java enum. Enumerations are generally a set of related constants. They have been in other programming languages like C++ from beginning. After JDK 1.4, Java designers decided to support it in Java also, and it was officially released in JDK 1.5 release. Enumeration in Java is supported by keyword enum. Enums are a special type of class that always extends java.lang.enum. An enum type is a special data type that enables for a variable to be a set of predefined constants. The variable must be equal to one of the values that have been predefined for it. Common examples include compass directions that are values of north, south, east, and west, and the days of the week.
In this tutorial, let's discuss about enums and how enums are used in Java. Enums are basically something which can contain different types of something. If you look at the example which you see on the screen, seasons. Different types of seasons are winter, spring, summer, and fall. And an enum helps you to declare a season as something which can either be just winter, spring, summer, or fall. That's basically what enum is all about. Let's now look at like the syntax of enum is very simple. Just like class, you have a keyword called enum. Enum space the name and open bracket, close bracket, and between that is the list of values. What we are seeing is just a basic enum. Let's now see how to make use of this enum in code. Okay, I'll say test creation of enum. That's basically what I'm going to do now. Let's try to create an enum from a string. Let's do that now. Enum. You can use an enum just like a type. So I would call it like just like we were. If season was a class, we would have said season. Season is equal to the direct way of creating an enum would be to directly say season dot fall. That's probably like the simplest way of creating a enum value is to just say season.fall. I'm basically not testing anything, I'm just testing Java here. So just let's go ahead and just run this test. Right click